Now, this question this year, when it came up, I would imagine most students, when they saw it, might think it's quite a complicated looking question, right? But the more you look at it, it's actually quite straightforward, right? The function that we're dealing with in this case, it tells you how many days it takes you to get to a certain amount of words per minute, right? That's when you're typing. Okay, and probably where the confusion arose in this case was that it was a natural logs function, right? And natural logs are it's quite an uncommon thing really to see a natural logs function. But part A, anyway, it's a very common type of question when we're dealing with functions, the factor theorem, or anything like that. Very often we're given there's an unknown variable in the function. In this case, it's k. Right, so I call these incomplete functions. We only want one unknown in there. We only want x to be the unknown. But in this case, there's a k as well. And lo and behold, in the first part, you're asked to figure out what k is. Okay, now just the first thing there to spot. See the way it says show that k is equal to that? A good bit of advice is when you see that, don't use this. Anytime you're asked to show something, don't use this and sub it back into the original function. You just basically want your answer to be that. Okay. And once you have that spotted, then it's an incomplete function. You're looking for clues. Okay, and it says that based on the function, Jack can learn to type 35 words per minute in that many days. All right, so that's your first clue. That's the clue that we're going to use to figure out k, and that roughly translates as when x is 35, then t of x is 35.96. Okay, and that's going to always be the case. You're going to be looking for clues that we can sub into this that'll help us figure out what k is. And another way of saying it is that this point is on that function. Okay, and back from junior cert functions and graphs, you know that if I input 35, then my output will be 35.96. So now we can solve this equation, and it's actually quite a simple equation to solve. We just want to get k on its own, so we divide across by this, and it comes out as minus 62.5. So we've showed our answer. Now the only reason they did that, sometimes they might just say, oh, solve for k, and not tell you this. But the reason they did this part is just because if you get this wrong, then basically the rest of the question is wrong. So they just show you the answer just in case anybody makes a mistake with that. Now, for part B then, find the words per minute that Jack can learn to type in 100 days of practice. And just keep in mind now that x is your words per minute. Okay, and 100 is the function calculate. The output of the function is the days. Right, now usually time is what was the variable. Usually if it's time, that's what goes in for x. But in this case, the output in this case is 100. So we want to know what value for x will give me an output of 100. So in this case, we're putting the function equal to 100, and we're trying to solve for x. Okay, so it's a type 2 question is what I call that. And this is where the algebra comes in then. Right, so you forget about all words per minute, and you can forget about all that kind of stuff. We now have an algebra equation, a natural logs equation that we need to solve. Okay, now the first thing you're going to do is get rid of the minus 62.5, just divide across by that. And now you can, if you want to, you can change that to decimals if you want, but I just like to leave the calculations to the end a lot of the time. But the next thing then is, how do I get rid of this ln then, this natural log? Right, and a well-prepared student will know straight away that to get rid of a natural log, you get the exponential of both sides. And watch how that's done. Now e always, when you have an e, it's always to the power of something. So you say e to the power of the left hand side is equal to e to the power of the right hand side, and this e and the natural log, this is one of the rules of natural logs and exponential functions, this e and that natural log will cancel. Right, so we're just left with the 1 minus 8, x over 80 here, and we're left with all of this over here, but we can type that into our calculator now later on. Now next of all, we're just going to balance the equation a small bit more, so we're going to take 1 from both sides. Finally, we get rid of the 80 by multiplying both sides by, or minus 80 in this case, and now we can just type all of that into our calculator now, and we get 63.84. So that's 63.84. To get to 63.84 words per minute, I would need 100 days of practice. Now, next up then, complete the table below. So now we just basically have to find this function, plot this function on a graph. And even if we weren't given the table here, I'm not actually going to use the table in this case. Look, we want to plot this function on this graph. We have our domain here. We have our list of inputs. Sub them into the function, and we get 0 for the first one, 8.34 for the second one. And use your calculator cleverly here, right? So you're just subbing 10, 20, 30, 40, 50, 60 all into your calculator, and you're getting your outputs then. So like, just be careful with your calculators, make sure you're not making any mistakes. You can do this very quickly if you just type out exactly this function and replace the x with 10, 20, 30 each time just using your calculator keys. So that's quite complicated, but you should be able to do that quite efficiently at this stage. Once you have that, then these are your coordinates. 30, 29 would be here, 50, 61 would be here, 70, 129 is up here. And you should also be kind of aware what an exponential or what a natural log function kind of looks like. Right, so it's going to be that kind of curve there. The reason it's going up like this is because it's a minus there, but look, you don't need to worry about that. Just you should know anyway that it's going to be that kind of smooth curve. Now, then it gets a bit interesting down here. So D, a simpler function that could also be used to model the number of days, is just P of x equals 1.5x. Now, straight away, and it says draw that on a graph. Now, straight away, you should be able to see that 1.5x, that's just a linear function. Right, now you can plot out your points if you want, but really you only need 2 points for this. Any of these 2 points, when you plot them, you should know they make a straight line like that. So if you just take the first point and the last point, that will do as well. But as you can see, it's a straight line that we have here. And what they're kind of saying here is that this function, 1.5x, does a very similar job to the exponential function, or the natural log function in this case, but it's obviously a lot simpler. Okay, but obviously it's a small bit less accurate then. If this is the perfectly accurate one, this one is a bit of an estimation, so it's slightly less accurate. So now at this point now we have A, B, C and D done. Right, so out of the 55 marks there's nothing really too challenging in there. Okay, and you should have no problem really getting full marks for all of that. Right, but the next couple of parts then are small but more challenging. It's just the wording of them. Right, so like when I saw this first, I hadn't a clue really what they were asking for here. Right, so h of x is equal to px minus t of x. What does that mean? But like it says, use your graphs then to estimate where h of x is equal to 0. So how are we going to do this? Because we know how to read things off the graph. Right, but that's something that we would rarely see really being asked to use a graph to solve this. But if you just write it out, we want to know where h of x is. We know h of x is equal to this. We want to know where h of x is equal to 0, so therefore we just put this equal to 0. And if we rearrange that, just get the t of x on the other side, we're actually looking for where p of x is equal to t of x. Right? So that would be, only a top student really would spot that. So really what they're looking for is the point of intersection. Okay, and that's, in this case, in 63. Now, next up, we get into a bit of calculus, and even if you're not quite sure, we can completely forget the context now, the words per minute for now, right? Because they say use calculus to get the maximum value, and even if you're not quite sure what it's going to mean in the long run, you should know straight away as soon as you see maximum value, you're thinking the maximum value is get the first derivative, put it equal to 0, and solve. Okay, so that's the key to this. Now, if you recall, h of x is that p of x minus t of x, right? And t of x is that, and p of x is that. So therefore, h of x must be simply that minus that. Now you see that becomes a plus there because it's minus 62.5. So we now need to get the derivative of this, put it equal to 0, and solve. Okay, so again, we can forget about all words per minute. Now it's just a calculus and an algebra question. Right, so step 1, find the first derivative. Now look carefully at how this is done. So 1.5x just goes to 1.5. Now, when you're differentiating this, right, the 62.5 isn't affected at all by the differentiation. So you keep the 62.5 the way it is. Okay. Now, if you want to do the chain rule for this, okay, and do it the long method for doing this, that's fine. But I just did it the kind of quick method, right? And if you're very familiar with how to differentiate, you'll know straight away that to differentiate natural logs, it's 1 over what's in the brackets, but it's multiplied then by the derivative of what's in the brackets. Right, so the derivative of this is just minus 1 over 80. So it's 1 over what's in the brackets multiplied by that. And if you want to simplify that out, just look carefully at this again now. So it's going to be 80 by 1, which is 80, and 80 by x over 80. The 80's cancel here, so that's why we're left with that x. And above the line then, look, it's just 62.5 by 1 by minus 1, so that's where that minus comes in there. Right, so that's quite complicated differentiation there now. But I know I keep saying it, but a well-prepared student will have no problem really with that. Okay, so now we have the first derivative and maximum value, put the first derivative equal to 0 and solve. So that's what we're going to do here, right? It's just simply solving this equation, and it'll be a shame now if you slipped up at this point. It's just a simple algebra equation. So get the 1.5 over to the left hand side, the minuses cancel, and we're just going to do a small bit of cross multiplication then to get rid of this x. So that's what that's going to look like. Multiply out your brackets, get x on its own, and we get 38.33. Now just watch out here now, we're looking for the maximum value of h of x. Now this is the value for x that gives us our maximum value, okay, but we actually want to find the maximum value itself, so we substitute it back into the original, and that's just going to look like that. And again, be careful with that. It'll be a shame now if you just made a mistake now with the substitution. If you want to do this over a couple of lines, get your natural log first, multiply by 62.5, add all of this, but we get 16.72. Now we can put it in coordinate form like that. And really that's your answer, right? You don't need to go any further than that. But let's just have a quick look, and again, you can skip this if you want, but it's always interesting to figure out what does this actually mean in relation to all of that. Now, I'm going to give you two explanations to this now, right? So you should recognize now that's the linear function that we were dealing with, and that's the natural log function that we're dealing with. This was the earlier question we had, where were the two of them the same? Okay, so that's straightforward enough. But if we were to take, what does our solution here in part 2, what does that solution actually mean? Well, if we were to plot this function, so we have p of x, that's the green, we have t of x, that's the blue, but if we were to put them both together and plot that function, it looks something like this. Okay, now again, you don't have to remember how to identify that or anything like that, but that's essentially what it would look like. And one way of explaining the maximum value is, look, you can see that it's just the highest point there is that. Okay, and that's straightforward enough, right? The maximum value, the highest point in the curve. But what does it actually mean in relation to this question? Now, if you recall, the natural log function here was a way of measuring the words per minute. Okay, how many days it takes to get to a certain words per minute. And let's just say, for argument's sake, that the blue one, the natural log one, is the 100% accurate one. Okay, and let's say the green one was just an approximation. Okay, well, what was t of x or h of x, sorry, what does h of x actually tell you? Well, it tells you the difference between the two approximations. Okay, and that's quite helpful, really, because like if the green one is an approximation, we want to know when is it different, right? And that's when we were doing this question, when we were asked where the two of them where p of x minus t of x is equal to 0, we wanted to know when was the difference between them 0. Right, because that's kind of helpful to know that after 63 days or whatever it was, there's no difference between the two functions. Okay, whereas what does that though? What about the maximum value for h of x? What does that mean? Well, what that translates as, when is the difference between the two functions at a maximum? Okay, so when is the least accurate time between the approximation and the actual true value? And that's where we get our 38.33. So this point is the least accurate approximation of p of x, is a way of saying it. So that's where you get your 38.33, right? 38.33 words per minute, that's where it's at its least accurate. Okay, now the question is though, and this is where it gets very interesting, is what does the 16.72 refer to? Right? Because it's not the number of days, okay? Well, interestingly, the 16.72 refers to how inaccurate it is. Okay, so that's the maximum difference, and it's 16.72 days in the difference between, is the maximum difference between the true value and the approximation.